So as you probably figured out by now, this chapter is pretty simple. Those of you who are already doing oceanography probably know that these are not the kinds of waves we talk about in real oceanography, but there are people who actually predict these waves for ships and so on. Wave forecast is a big business. We mostly talk about planetary waves, but nonetheless, we will go through these. We'll go through tides, tsunamis at the end of this chapter, tides in the next chapter, because these are kind of an important part of elementary oceanography. And for those who are in previous or other stages of their education, they probably need these as a part of their introductory oceanography. So we'll quickly see the wave interference patterns. As you probably learned in your physics experiments, physics lessons, there are constructive interferences and there are destructive interferences. So you can get, if you have a constructive interference, you have two waveforms with crests and crests combining, troughs and troughs combining, so you're going to exaggerate the entire wave and make it grow. So this 1 and 2 are combining to form 3. If you have destructive interference, then the crest of one probably hits the trough of the other one or somewhere in the middle, and you're going to end up with here it's completely cancelling and end up becoming a flat surface. And you can have mixed interference where you have different waveforms combining to form ups and downs. Okay, so very simple concept, but actually in reality it is an important concept. Anywhere you go, every time you go to the lake or ocean or river or whatever, if you have interferences or rocks and jetties or some kind of construction that's getting in the way of the flow, then you probably will see some form of wave interference happening. So here it is showing observed wave pattern as a cross section, and you can see different waveforms are coming in the middle. They are producing a very different waveform than the original waves that are coming into this interference region. Okay, so two swells with different wavelengths and different wave heights are being combined here, and swells you can recognize by these nicely sorted troughs and crests, right? Long, nicely sorted, smooth moving wave forms coming along and meeting in the middle. This obviously leads to constructive interferences that are seriously damaging, like the USS Ramapo that we talked about, that broke the old rule of maximum wave height. And there are many places where rogue waves occur fairly routinely. Those are kind of regions that we will look at on a map. So massive spontaneous solitary ocean waves, so you will be seeing nice little waves around and suddenly you will get a monster wave in the middle because of these incredible constructive interferences, and they reach these abnormal heights that we talked about, like 30 how much was it, 36 meters, 11 floors, right? And they have enormous destructive power because wave energy is proportional to the square of the wave height. So if you have huge wave height, you have huge energy. Okay, so luxury liner Michelangelo got damaged in 1966, and Perfect Storm, which is a very nice book by, I think, Carl Jung, his name I forgot, and it's a nice movie with great special effects. I think it's George Clooney, so you can see the special effects there. And this is image of some ships being damaged by these rogue waves. So what happens in a rogue wave? They are difficult to forecast because you don't know exactly which waves are going to manage to constructively interfere to produce these massive rogue wave out of nowhere. They tend to occur more near weather fronts and downwind of islands, because islands generate waves as the winds blow. The islands act as a blockage that then produces downstream waves. So downwind of the islands you have waves, and oftentimes they're also combined with currents which are pushing against the waves, and the waves can rise. So weather fronts produce these kind of convergences that we talked about. So essentially, in a cartoonish way, you have a ship that is going along happily, doesn't know there is a rogue wave coming along, and ships move slowly and the rogue waves move fast, right? So the rogue wave is right upon them and they cannot steer around it, away from it, or back from it. So then the ship sinks. As I said, in the Antarctic region with a lot of storm wave movement, it's a hot spot for rogue waves. As I said, huge containers every year disappear because of rogue waves, and many small ships also disappear. So just remember the terminology rogue waves, and comes directly out of this wave interference, constructive interference, and wave height squared, hence it has a lot of energy, can break the ship into half. Okay, not a funny thing.